Hello, ladies and gentlemen. Today we are going to be reviewing inequalities. So what is an inequality and why are they important? How can we graph them? So by the end of the day, you'll be able to understand what an inequality is, and you will accomplish this by comparing values and graphing our solution set on a number line. To start with here, I'm going to have you guys watch a little video on YouTube that kind of runs down what inequality is, gives you some review, some background, and then we'll look from there. Trying to move my tools out of the way. There we go.
In this video, we're going to cover the basics of inequalities. So we'll take a look at what all the different symbols mean, and also at how to represent inequalities on a number line. Let's start with the symbols. If we look at this expression, it means that x is less than 10. So x could be 9, or 8, or 3, or negative 4. Basically anything that's less than 10. Whereas if we had this expression, this one means that x is more than 10. So a number like 11, 12, 50, or 200. The thing that students normally find hardest about this topic, though, is just remembering which symbol's which. So one way that might help you remember it is to remember that the less than sign looks a little bit like an L. So L for less than. And if you can remember that, then you know that the other sign, which doesn't look like an L, must be the more than sign. The next thing we need to look at are these two symbols, which look pretty much the same as our less than and more than signs, except they also have these horizontal lines underneath them. The straight lines basically mean or equal to. So this first expression means that x is less than or equal to 10. So as well as being numbers like 9, 8, 3, or negative 4, x could also be 10 itself. Similarly, the second expression means that x is more than or equal to 10. So again, the number might be 10 itself, or any number bigger than 10. Another important thing to know is that when we take an expression like x is less than 10, that means exactly the same thing as 10 is more than x. In both cases, we're saying that 10 is a bigger value and x is a smaller value. We can also use negative numbers with inequalities. For example, x is less than a negative 5. It means that x can be any value smaller than negative 5. For example, negative 5.5, negative 17, negative 100, and so on.
All right, I'm going to pause the video there and get back to our presentation. So that hopefully gives you a reminder as to what an inequality is. And, an inequality helps us compare different values and determine which values are greater than, less than, and or equal to the other values, okay? And we use those different inequality symbols as you saw there, okay? And we'll talk about what those are. Or he talked about what those were. So as we read this here, okay, we see that this is x, and then we have to remember that this is less than. He said that it's less than because it looks kind of like an L. Now, the way I remember it is that this side, look at here, this side comes down to a little tiny point right there. So things that are on this side of that inequality symbol are smaller than things that are on this side where it opens up really big, right? So this side, we're always reading from left to right, this x is going to be smaller than what's over here, or less than what's over here, okay, or fewer than. So we can think of this as x is less than 7. Remember, this line underneath here is going to imply also that this value can be equal to. So this is x is, and then notice it's on the bigger side, reading from left to right, it's on the bigger side. So x is greater than 13 or equal to. So x is greater than or equal to 13. X is greater than or equal to 13. Go ahead and see if you can write this one out. What would this be? All right, so hopefully you got that x is less than. Again, notice it's on the smaller side of this inequality symbol. So x is less than. And then it also has a line underneath, implying that x could be also equal to. -6. All right, so hopefully that kind of reviews and refreshes you as far as what these inequality symbols mean and how we can read them and talk about them. Let's go to our next slide here. Sometimes you're going to see inequalities that are written with the variable on the right side. Okay, now we want to rewrite these variables anytime we see them so that the variable is on the left side, because we care about how x compares to different values, not how 2 compares to x. So if you think about it, you would want to read this from this way, from x is greater than 2, but we don't read from right to left, so we need to rewrite this so that x is, and then notice x is greater than, it's on the bigger side of this inequality symbol. So we need to flip that inequality symbol around so that x is still on the greater side of that inequality symbol. And then we just put the 2 there. Doing the same here. Again, we want to write the x on the left side. And x is on the smaller side of the inequality symbol. And don't forget about our equal to, -3. Let's go see what's next here. Oops, I forgot to clear that out. There we go. Okay, so I'd like you to rewrite these inequalities so that the variables are on the left side. Now you can't write these inequality symbols in Edpuzzle, but I'd like you to think about it. Write them down on a piece of paper. All right, hopefully you did that, and we'll see that if you wrote this so that x is on the left side, it would end up being x is greater than or equal to 17. For this one here, x is, it's on the smaller side, is less than -20. All right, let's go ahead and move on. Now we're going to be looking at graphing inequalities. Okay, the graph of an inequality shows all the solutions of an inequality on a number line. So for example, if we have x is greater than 2, on our number line, we're going to graph all values that are greater than 2. Here is 2, and we're going to say, starting at 2, we want all values greater than 2. So we'd shade to the right here, all values greater than 2. Now in this case, we're going to have an open circle. Okay, if there was a line underneath here, if we're including 2 in our solution set because 2 is equal to 2, then we're going to shade that in. We're going to make it a closed circle. So that's something we're going to talk about here, the difference between an open circle or a closed circle. Now, if it's an open circle, we are looking at just the less than. So anytime you see a less than symbol or greater than symbol, in both those cases, you're going to use an open circle because we do not want to include that value in the solution set. So for example here, again, if we had just x is greater than 2, we're going to have an open circle here. Okay? Because 2 is not greater than 2. It is not part of our solution set. We're not going to shade that in. For a closed circle, that's when we have the less than or equal to. Less than or equal to. Okay, and that is less than or equal to, or greater than. Or equal to. Okay, and in those cases, we're going to use a closed circle because our solution could be, if we have x is greater than or equal to 2, then we want to include 2 in our solution set. So we're going to shade in the 2 as part of our solution set. Clear that last page. All right. So let's go ahead and try this out. I'm going to start actually right here with the number. What number are we starting on here? We're starting on 2. Okay, so we're going to start at positive 2. And do we want an open or closed circle at 2? We're going to want an open circle because it is just less than. All values less than 2. And then if we want all values less than 2, where are values less than 2? Are they to the left here or are they to the right? You'll see that all values less than 2 are to the left. So we're going to shade to the left. And notice I put an arrow at the end here because that implies that this shading goes on and on and on and on all the way to negative infinity. Okay, and all these solutions are part of our solution set. But notice 2 is not part of our solution set, but we have to start there because even just the smallest value less than 2 is part of our solution set. Got another example for you guys to try. Again, I want to start with what number do we start with here? And hopefully you said -3. We're going to start at -3. Okay. Do we want an open or closed circle at -3? We're going to want a closed circle because it is greater than or equal to. So we're going to shade that in because -3 is part of our solution set. And then which way do we want to shade? Do we want to shade to the right or to the left for values greater than -3? We're going to want to shade to the right. All right, all values greater than -3 are to the right. And there we go. And again, we put an arrow at the end to show that that's going to go on forever. It doesn't just end because our number line ends. It goes on and on and on and on and on and on and on. All right, go ahead and let's practice graphing this. Where are you going to start? What number are you starting on? Hopefully you said -1. Do you want an open circle or a closed circle? We want an open circle since it is just greater than. And then we're going to shade all values which direction? To the right or to the left? We're going to shade all values to the right. Next problem. Okay, y is less than or equal to 2. Which number do you want to start on? We're going to start on 2. Should that be an open or closed circle? It's going to be a closed circle right there because we want to include 2 because 2 is equal to 2. So 2 is part of our solution set. And then we want all values less than. Are you going to shade to the left or are you going to shade to the right? And we are going to shade to the right. Because that's where all values are less than 2. 1 is less than 2, 0 is less than 2, -1 is less than 2, 1/2 is less than 2, right? There's all these values in here. And then it goes on beyond here even, right? -6, -7, -8, -9, -10, -1,000 is less than 2. All right, I'm gonna skip that. And there you go. IXL, you're going to be working on T2. That's going to give you the opportunity to practice graphing those inequalities on a number line, get practice with those open or closed circles, and which direction to shade. Good luck.